Hello and welcome to this new series of videos that I'm doing that I'm calling Snippets. So what I'm going to be doing in these is I'm going to be taking a look at how I've solved particular problems in some of the games that I'm building and looking at sort of why I've solved them. So these are just going to be short videos, and the idea is to kind of give you a bit of an insight into my thought process and how I've approached solving it. Now, the approaches, they're going to be one way of solving it. They're going to be one of the ways that you can solve it and how I've solved it in this particular case. There's going to be multiple ways for solving these. I just want to show you how I've approached it and kind of explain how and why I've come up with, the particular solutions that I have. So for this first one, what I'm going to take a look at is the camera that I set up for the Osiris initiative. So I'm going to show you how that camera works and why I've structured it the way that I have. So let's dive on in and take a look. Okay, so before I look at how the camera is actually set up, let's take a look at how it actually works. So I can move around the world using, in this case I'm using WASD for moving around, but basically I'm moving around and you'll notice that the position is changing of the camera but the orientation is not. So it's staying looking at this fixed angle as I'm moving around. Now, what I want you to pay attention to is now when I zoom in. So when I zoom in, you'll notice that the camera is actually moving lower, so the camera is getting closer, but it's also tilting. So this was the effect that I wanted with this, that the camera, as you zoomed in, it didn't just zoom down, it actually tilted, so it was not pointing directly forward, but so that it was pointing more forward, so that you kind of got this closer up perspective on what you were looking at. And then as you zoom out, the camera is moving up and then it's starting to tilt. And if you zoom out entirely, so to the maximum extent that the camera has, then you end up in this pretty much top-down viewpoint. It's not perfectly top-down, but it's pretty close to being top-down viewpoint. So if we go to the scene, so if I move this so that I can actually see the game and the scene at the same point in time, because what I want to do is I want to select the camera here so that you can see sort of how the camera is moving, not just actually how it's moving in the game, but how it's actually moving here when I zoom in. So if you watch, as I zoom in, the actual camera is moving down, and you can see that tilting forward behavior. So let's take a look at how I actually put this together. So what I've worked out for this, like I was saying before, this is one way of approaching it. There are a whole bunch of different ways that you can approach things like this. So before I dive into the code, let's first take a look at how the camera itself is actually structured. So the camera here, it's on this camera controller object, and the camera is actually a child of that. And what you'll notice is the camera is there and it's rotated with respect to the parent, so it's rotated with respect to the camera controller. But the camera controller, it's at the sort of standard orientation. It's at the orientation that matches the world. The reason I've done this is so when you are tilting, it tilts the camera. But when you move around the world, so when you're moving horizontally, it does that by moving this camera controller object. So if you want to have that behavior where you want to be able to tilt the camera, but also you want to be able to move it around, making the camera a child of another object is a really handy way of doing that. So all of the logic for this is in my camera controller script. So let's take a look at that script. So what we've got here, let's go and have a bit of a look at what's happening. So everything is tied to this concept of a zoom level that goes from 0 to 1. So I did that because I wanted to have basically a setup that made it a little bit easier for me to be able to control sort of where the zoom was at. I wanted to be able to say, okay, this is 25% zoom, 50%, 100%. Just made the maths a little bit easier later on. So here in Update for the camera controller, this is where I'm handling in part that horizontal movement. And I'm not doing anything particularly clever here. I'm getting my input axes in horizontal and vertical, I'm scaling them by a speed by delta time. This is a reasonably conventional approach. The reason for using a speed by delta time is that way then you get a movement that tends to be smoother regardless of the frame rate. So that's working out my position delta. Now I'm checking here if the square of that magnitude is greater than 0. And the reason that I'm doing that is in part for setting this camera change to true. Because one of the things my camera does is it actually emits notifications when anything has changed with the camera. So when it's moved about the world or when the zoom level has changed. I use that because I have some bits of UI that are placed in the world. So not as an overlay, but are actually embedded in the world. And having these notifications allows me to actually scale my UI or have my UI react to the camera changes. So this block here is purely, that's just handling that lateral movement and working out if I have moved the actual sort of camera. And then I'm applying the movement to that. Now you'll notice here I'm using this camera bounds closest point. That's because I have a bounding box in the world, and that bounding box, which you can see it's set up here, it's centered on where the camera object is initially placed. And I use that to prevent the movement from going outside of the permitted area. So closest bounds gives you the closest location on the edge of a box if the point is outside of it, or if the point is within inside the box, then you just get that same point back. Now this next bit here is handling the zoom, which at the moment I have this tied specifically to the scroll wheel. So similar to the horizontal movement, I have a zoom speed and I have a delta time. So I have, that same concept. Now the scroll input here, I actually clamp how much you can move per time. So the reason I have that clamping of the amount that it's changing the scroll input by is just to actually make it so that there is a upper limit on how fast the camera can move. So there's not a lower limit, so there's not a minimum amount of movement it will do, but there is a maximum amount, and that just gives a more consistent experience regardless of what sort of mouse the person has. I have an option for inverting the scroll because I know that's something that some players want, so there's an invert scroll option if people want. And then I work out the new zoom level. So the new zoom level is from 0 to 1, and that's taking whatever my current zoom is, and that's applying this scroll input to it. So it's using that to work out what the new input's going to be. And again, it's working out if the camera's changed, so that I can feed that information through. And then it runs this set zoom level function. That one handles the pitching of the camera, it handles the height that the camera can be moved to. And then the final part that I do, if the camera was changed, is I notify anything that's listening to this. So in the zoom level, then what it's doing, if for whatever reason you've called this and the zoom level hasn't changed, then it skips over it all. That just avoids doing all of this extra maths when I don't need to. So one of the things that I do is I don't use that zoom level directly. I actually run that zoom level, that 0 to 1, I run that through a cosine function. I still get out of that a 0 to 1, but it's changed the shape of it a little bit. So rather than being a straight line, it's now got a period that's relatively linear in the center. So in the middle of the zoom area, you get a large amount of change, but at the minimum and maximum zoom, then you get a much sort of finer grained control. And that gave kind of the effect that I wanted. There's probably other ways to do this. I could have done this using a setup where I set up an animation curve and tied into that. This was just something that was fairly quick and easy and that made sense to me as a way to do it. But this is how I've done it, and it's purely to get that kind of nicer movement that I was going for. So I have a minimum and a maximum angle that the camera can be pitched at, and I lerp, so a linear interpolation, based on that zoom level between those angles, and I use that for rotating the camera. And I also have a minimum and a maximum height, and so I lerp between those two heights. So the zoom, it's doing a lerp between the height ranges and the angle ranges, and the progress factor that it's using for the lerp, it's the zoom level, but it's the zoom level run through cosine so that it smooths it out at the start and the end, so basically at the minimum and maximum zoom levels. And then I have my setup for the callbacks for those notifications. So that's how the camera works, and you'll see if I look at the camera, I've got my scale factors for the movement speed in horizontal and vertical. I have my camera angles that it lerps between and my camera heights, and my zoom speed and the clamping on how much it can zoom. So that's not actually too much code in there, but it gives you a camera that behaves quite nicely for this sort of style where you want to be able to zoom in and get a nice close-up view of what you've got there in your world, but you also might want to at times zoom out to a top-down viewpoint. If you've got any questions on this, then leave a comment below. If you've got any ideas on how you might approach this differently, then please leave them below. I'm curious to hear of other ways that people have approached this problem. If you've enjoyed the video, then give it a thumbs up, and if you want to see more like this, then subscribe. But until next time, bye.